Hello everyone and welcome to my lesson on squashing and stretching forces. As you already know, forces can change the shape of objects and this is called deformation. There are two ways they can do this. So when forces squash an object, they cause compression. For example, when you squash a can. Forces that stretch an object, they cause tension, like stretching an elastic band. Both of these forces cause the object to deform or change shape. Next, I'm going to show you a video of a tennis ball hitting the ground. What I'd like you to do is, after you've seen this video, there's going to be a question for you to answer. Whilst you answer the question, I recommend that you pause the video. Here is your question. Describe what happens to a tennis ball when it hits the ground. You could say this out loud, or your teacher might have asked you to write this down in your books. Pause the video now and come back to see the answer. Great, you've had a go. So let's see what I would write if I was going to answer this question. So I would say that when the tennis ball hits the floor, it deforms or changes shape. The force of the tennis ball hitting the floor causes compression. It is squashed. The ball is no longer a spherical shape, it becomes elliptical or oval shaped. Hopefully you've got something similar. So now we're going to talk about why the ball bounces. How can the floor push you up? So consider this camel. We can call him Bob. Bob is standing on the floor, and the forces acting on him are weight and reaction force. Now we know these forces are balanced because the camel is staying stood on the floor. He's not floating up and he is not falling through the floor. But what is reaction force? We haven't really looked at that yet. So the floor pushes you up when you stand on it. It might seem strange to talk about the floor exerting a force on you because you can't see anything happening. But the floor is a solid, and as you know, solids are made up of particles arranged in a regular pattern, as shown in my picture here. The particles are joined strongly together by bonds. And so when you stand on the floor, your weight pushes those particles together. The bonds are compressed or squashed closer together, and they push back and support you. Solid materials are only compressed a very small amount when you apply a force on them. And so the reaction force is the support force from an object you are sitting on or standing on or lying on. Okay, let's move on now to stretching. Things like bungee cords or springs, they stretch when you exert a force on them. And the amount these stretch is called the extension. Now springs are very special, and the extension of a spring can be used in an interesting way. So if you double the force on a spring, the extension of that spring will double. And this is called Hooke's law. And you can use the length of a spring to measure the size of the force because of this special relationship. Now, you are going to have a go using a virtual simulator online at seeing what happens when you start adding masses to a spring and how Hooke's law works. You're going to need to open the simulator instructions and work your way through the worksheet. Now, if you get stuck or you need any help, I've made a step-by-step help video that shows you how to use the simulator and also how to record your results in the Excel file. Thanks very much.